What if the universe has been offering us a humbling thought all along, that Earth is precious, but not necessarily the finest place life could ever call home? For most of human history, we looked at the night sky as if it were a ceiling, a dark, elegant limit. The stars seemed fixed, distant, almost ceremonial in their silence, and beneath them, we built a story around ourselves, that this world, with its oceans and seasons and narrow belt of breathable air, might be the rare exception in an indifferent cosmos. It was a comforting idea. It made our fragility feel meaningful. But science has a way of loosening the grip of comfort. Over the last few decades, telescope by telescope, signal by signal, that old picture has begun to change. Hidden in faint dips of starlight, in the trembling motion of distant suns, astronomers have found worlds that do not simply echo Earth, but in some cases seem to improve on its luck. Planets with longer lifespans, more stable climates, deeper oceans, gentler stellar futures, places where life, if it ever began, may have had far more time than it has had here. That possibility does not diminish Earth. If anything, it makes our planet feel more intimate, more temporary. We begin to see our world not as the center of creation, but as one chapter in a much larger story of habitability, chance, and endurance. This is that story. It is a journey through distant systems and uncertain evidence, through red suns and ocean worlds, through the uneasy border between data and imagination. And at its heart is a question that is as scientific as it is deeply human. If life is shaped by time, climate, and cosmic patience, then what kinds of worlds might surpass our own? And what would that mean for the way we understand ourselves? What if the search for a better world begins not with a grand discovery, but with a faint and almost forgettable flicker of light? That is often how these stories start. Not with a spaceship, not with a map, but with patience. A telescope stares for months, sometimes years, at a single star. Then, for a few hours, that star dims by a fraction so small it would mean nothing to an untrained eye. Yet to astronomers, that tiny hesitation can signal the passage of a planet crossing the face of its sun, a shadow millions of miles away, briefly interrupting the ordinary. From those shadows, an entire hidden geography begins to emerge. Scientists can estimate a planet's size from the depth of the dimming. They can infer its year from the rhythm of repeating transits. In some cases, by watching how the parent star subtly wobbles under the pull of orbiting bodies, they can even guess the planet's mass. And from that mass and size, a rough portrait appears. Rocky or gaseous, dense or light, scorching or temperate. It is a strange act of seeing. We do not look directly. We reconstruct. We listen to gravity. We study absence. And what we have found is astonishing. The galaxy is not sparsely populated with planets. It is crowded with them. Worlds seem to form as naturally as stones in a riverbed. Some hug their stars in brutal heat. Others drift in frozen darkness. But among them are a smaller, more intriguing few, planets that sit in the delicate range where liquid water may exist, where chemistry might remain active, where life could, at least in principle, endure. The search is not really for a second Earth. That phrase is too small now. Increasingly, the deeper question is whether Earth itself is only average. If our planet was not the final model, but an early draft, what else might the universe have written in quieter, older systems where conditions have remained gentle for far longer than they have here? What if Earth's greatest strength, its living richness, its restless energy, is also the reason it may never have been the easiest place for life to flourish? Seen from a distance, our planet looks serene. Blue water, white clouds, brown and green continents turning slowly in sunlight. It appears balanced, almost composed. But life on Earth has survived not because conditions were always gentle, but because it learned to persist through upheaval. Our history is written in collisions, ice ages, supervolcanoes, mass extinctions, and shifting seas. Again and again, the world has changed the rules. This instability may be part of what made complex life possible. Tectonic plates recycled carbon and minerals. A large moon steadied the planet's tilt. A magnetic field deflected much of the solar wind. The atmosphere evolved through deep exchanges between geology and biology. Earth is not merely habitable, it is dynamic, alive in the fullest sense. But dynamism comes at a cost. A world that supports life for billions of years is not necessarily a world that makes survival easy. That realization has changed how some scientists think about the cosmos. Habitability is no longer a simple checklist of distance from a star and the presence of water. It is a more delicate equation involving stellar temperament, planetary age, atmospheric chemistry, radiation levels, geological calm, and time. Perhaps above all, time. Life may need not just the right ingredients, but long stretches of relative peace. In that light, Earth begins to look less like perfection and more like resilience. A planet that worked, but under pressure. A world that produced consciousness through difficulty, not comfort. And once that possibility enters the conversation, another follows close behind. Somewhere out there, maybe planets where the climate is steadier, the star quieter, the window for evolution far longer. Not better in every sense, but better perhaps at giving life room to breathe. If struggle shaped us into who we are, what might emerge on a world where existence was never quite so hard won? What if the best home for life is not a planet that looks most like Earth, but one that has simply had more time to become kind? In the search for habitable worlds, age matters in a way that feels almost poetic. Earth is about 4.5 billion years old, and complex life arrived only after an immense wait. For much of our planet's history, there were only microbes, quiet and persistent, reshaping the atmosphere one unseen exchange at a time. Intelligence, at least in the form we know, came very late. That suggests something profound. Life may not need rare magic so much as extraordinary patience. This is why astronomers have become interested in stars smaller and calmer than our Sun, particularly long-lived orange dwarfs. These stars burn more slowly, more steadily, and far longer than Sun-like stars. They may offer billions upon billions of extra years for biology to experiment, adapt, fail, and begin again. Around such stars, a planet could remain in the habitable zone long after Earth itself has become too hot for oceans and forests to endure. It is a quiet shift in perspective. For generations, our Sun felt like a model star, bright, stable, familiar, but in cosmic terms, it may be somewhat impatient. A world orbiting a more moderate star might enjoy a climate that changes less violently over deep time. Seasons may remain gentle. Energy may arrive more consistently. Evolution may proceed not in desperate leaps, but in long, uninterrupted conversations between ocean, sky, and stone. Of course, age alone guarantees nothing. A planet may be old and barren, warm and toxic, stable and lifeless. Yet the idea lingers because it touches something larger than astronomy. It asks us to imagine that the universe may reward endurance more than brilliance. Earth gave life a narrow and beautiful chance. But elsewhere, there may be worlds where the chance was wider, the clock more generous, and the silence between catastrophes long enough for life to become something we have not yet learned how to imagine. And if time is the hidden ingredient, then perhaps the most promising worlds are not the youngest or the brightest, but the ones that have waited longest in the dark. What if one of the most promising worlds in the cosmos circles a star so ordinary that, from a distance, no one would think to call it remarkable? In the constellation Libra, about 100 light-years from Earth, a planet known as Gliese 581g once captured the public imagination as a possible turning point. Its existence became a subject of debate, challenged by later observations and statistical caution. Yet the fascination it sparked has endured for a reason. It represented more than a single target. It marked the moment when the idea of a potentially habitable world stopped feeling abstract and began to feel close enough to name. Around the same time, astronomers were finding other candidates in similarly modest systems, rocky planets orbiting smaller stars, worlds that might sit within a temperature range gentle enough for liquid water. These discoveries did not offer certainty. They offered silhouettes, a radius here, a mass estimate there, the rough suggestion of stone instead of gas, of temperate orbit instead of scorching proximity. And still, even those fragments were enough to widen the imagination. A star does not have to be grand to host something extraordinary. In fact, the quieter stars may be the more forgiving ones. Smaller suns burn with less haste. Their habitable zones lie closer in, and while that creates its own complications, it also opens the possibility that life-friendly worlds may be far more common than earlier generations dared believe. Not rare sanctuaries, but recurring themes. There is something deeply human in this pattern. We expect significance to announce itself. We imagine it wrapped in spectacle, but the universe often works in subtler ways. The places most worth noticing may not shine the brightest. They may simply endure. They may circle dimmer stars in longer silences, waiting for instruments sensitive enough and minds humble enough to see them. So much of this search remains unresolved. Some planets will fade from the catalogue as methods improve. Others will become stronger candidates. But even uncertainty has changed us, because once a world can be imagined in detail, even imperfectly, it begins to alter the map of possibility. And after that, the question is no longer whether Earth is unique, but how many quiet alternatives have been there all along. What if the most life-friendly places in the universe are not Earth-like continents beneath familiar skies, but worlds almost entirely made of water? There is something instinctively inviting about an ocean planet. We imagine a globe wrapped in deep blue, clouds drifting above a horizon with no land in sight, sunlight moving across waves that have never touched a shore. On Earth, water is the medium through which life first learned to stir. It softens extremes, stores heat, carries minerals, and makes chemistry mobile. So when astronomers find planets that may hold far more water than our own, the idea carries a particular emotional weight. It feels less like fantasy than memory. Some of these worlds are believed to be larger than Earth, but still rocky enough to avoid becoming gas giants. They belong to a category sometimes called super-Earths, and a few may contain vast global oceans hundreds of miles deep. If their atmospheres are stable and their temperatures moderate, such planets could offer long-lasting environments where life has both shelter and continuity. Water, after all, is not just a resource. It is a stabilizer. It slows change. It absorbs shock. But abundance can create its own mystery. A world covered entirely by ocean may lack exposed land, and with it, the cycles of weathering and mineral exchange that help regulate climate on Earth. At great depths, pressure could turn water into exotic forms of ice, unknown in everyday life, building invisible barriers between surface oceans and rocky interiors. The very feature that makes these planets seem generous could also make them strange in ways we do not yet understand. Still, they remain compelling because they challenge our biases. We often search for familiar landscapes, coastlines, forests, mountains, something that resembles home. Yet life may not need resemblance. It may only need continuity, energy, and time. A planet does not have to mirror Earth to surpass it in habitability. And perhaps that is the larger lesson. We are not looking for a duplicate of our world, preserved elsewhere like a backup copy. We are learning to imagine that life might thrive under conditions that feel alien to us, but natural to the cosmos. If water is memory's oldest companion, then maybe some distant oceans have been remembering life far longer than Earth ever could. What if a world slightly larger than Earth, orbiting a quieter star, offers the kind of balance our planet has only achieved in fragments? Among the many candidates that have drawn scientific interest, planets like Kepler 442b have come to symbolize a new category of hope. Not because we know them intimately, we do not, but because their basic measurements suggest a rare and appealing compromise. Rocky enough to matter, temperate enough to imagine, positioned in a region where starlight may fall softly enough for water to remain liquid, yet steadily enough to support a long climate story. Kepler 442 is often described in cautious terms, and caution is deserved. We cannot yet walk its surface, taste its air, or watch its weather roll over an alien sea. What we have are clues: its size, its orbit, the character of its host star. But those clues invite a powerful thought. A planet only modestly larger than Earth may hold heat differently, preserve its atmosphere more effectively, and maintain geological activity without descending into the violence that has so often reshaped our own world. There is elegance in moderation. Too small, and a planet loses its air and inner warmth. Too large, and it risks becoming something entirely different, thick with crushing atmospheres or buried under immense pressures. Somewhere between those extremes lies a narrow architecture of possibility, a world with enough gravity to hold on, enough mass to endure, enough calm to let biology become patient. That patience may be everything. On Earth, evolution advanced through interruptions, impacts, extinctions, sudden turns in climate and chemistry. But on a more stable planet, change might arrive less as catastrophe and more as conversation. Life could diversify in slower, subtler rhythms. Complexity might not need to recover so often from collapse. It might simply continue. We tend to imagine greatness in dramatic terms. Yet some of the best worlds may be the gentlest ones, places where nothing extraordinary had to happen for life to survive. And if that is true, then perhaps the universe's most profound achievements are not forged in turmoil, but nurtured in long seasons of quiet light. What if the stars we once ignored, small, cool, reddish, almost modest in their light, turn out to host the greatest number of living worlds? Red dwarfs are the most common stars in the galaxy. For a long time, that fact felt more statistical than meaningful. These stars are dimmer than the sun, smaller, slower, easier to overlook. But abundance changes the stakes. If even a fraction of them possess rocky planets in the right orbital range, then the Milky Way may be filled with potential habitats far beyond anything earlier generations imagined. And yet red dwarfs come with a complication that feels almost like character. In youth, Many are unruly. They flare. They throw bursts of radiation into surrounding space. Their habitable zones lie close in, forcing planets to orbit tightly, sometimes so tightly that one side may face the star forever, while the other remains in permanent night. It is a difficult image to love at first. A world split between day and darkness does not sound hospitable. It sounds divided, but nature is often more flexible than intuition. With a thick enough atmosphere or vast oceans to move heat around the globe, such a planet might avoid those brutal extremes. Winds could carry warmth across the terminator line where day meets night. Clouds might gather on the bright side, reflecting radiation back into space. In some models, the most temperate region would not be the blazing noon or frozen midnight, but the long band of twilight between them, a place of perpetual dawn and dusk, where the light never fully arrives and never fully leaves. There is something hauntingly beautiful in that possibility. Life under a red dwarf may grow in rhythms unlike anything on Earth, beneath a sky tinted by a different sun, shaped by a steadier gravity of shadows and glow. The familiar would vanish, but the essential things, energy, chemistry, time, might still remain. Perhaps that is what makes these stars so important. They remind us that habitability is not comfort as we define it. It is adaptability within constraint. And somewhere in those dim systems, under quiet red light, life may have learned to flourish, not despite strangeness, but because of it. What if the most revealing measure of a world is not how closely it resembles Earth, but how gently its star has treated it over time? A planet lives at the mercy of its sun. That fact sounds simple, almost obvious, yet it may be the difference between a world that briefly permits life and one that sustains it for ages. Stars are not just lamps in the dark, they are temperaments. Some burn with a measured steadiness. Others pulse, flare, and slowly intensify until the very planets that once depended on them are pushed beyond their limits. In that long relationship between star and world, habitability becomes less a location than a duration. Earth has been fortunate, but not permanently so. The sun, for all its life-giving warmth, is brightening over geological time. Long before it dies, it will likely render our planet hostile to oceans, forests, and the fragile complexity we call civilization. This means Earth's habitable era, generous as it feels to us, is still a finite interval. It has a beginning, a middle, and an eventual end. That realization changes the search. Scientists have begun to ask not only where a planet sits today, but how long it has remained in a stable, life-friendly zone, and how long it might continue to remain there. A world with a longer habitable future may offer biology something Earth cannot: more time to experiment, more time to diversify, more time for intelligence, memory, culture, or forms of awareness stranger than our own. Time deepens everything. On Earth, life needed billions of years to move from single cells to forests, animals, and minds capable of wondering about other skies. If another planet enjoyed a quieter star and a longer climatic calm, then evolution there may not simply match our story, it may outrun it. There is humility in that thought. We are accustomed to measuring the cosmos against ourselves, asking whether another place could support life as we know it. But perhaps the better question is whether some worlds have already had the chance to become more intricate, more ancient, more practiced at being alive. And if habitability is really a matter of endurance, then the finest worlds may not be those most like Earth today, but those with the longest tomorrow. What if the idea of a better planet says as much about us as it does about the worlds we are trying to imagine? Behind every catalogue of promising exoplanets lies a quiet human habit, We judge the unknown by the terms of our own survival. We ask whether a distant world has water, breathable air, tolerable temperatures, a stable orbit. We search for conditions that would allow our bodies, or something like them, to endure. It is a practical instinct, but it is also a revealing one. When we describe another planet as better for life than Earth, we are really speaking from within the limits of earthly experience. And yet the deeper science keeps widening those limits. Researchers have begun to imagine superhabitable worlds, planets not identical to Earth, but perhaps more favorable in certain ways. Slightly warmer, though not too warm. Slightly larger, though still rocky. Wrapped in thicker atmospheres, with broader shallow seas, longer-lasting internal heat, and stars that age more slowly. The concept is not a claim that such worlds are paradise. It is an invitation to think beyond loyalty to the familiar. Evolution does not owe its best work to our preferred scenery. This shift carries an emotional consequence. Earth becomes less the universal standard and more a beloved local example, not the measure of all living worlds, but one successful expression among many possible forms of balance. That perspective can feel unsettling at first. It moves us from the center to the chorus, but there is beauty in that displacement. It suggests the cosmos may be more generous than our oldest myths allowed. We are still far from certainty. A planet can look ideal from a distance and turn out to be harsh beyond expectation. Atmospheres deceive, stars change, chemistry surprises us. But even with those cautions, the search itself has become meaningful. It teaches us to hold confidence and humility in the same hand. Because the farther we look, the more we discover that life may not belong to one perfect template. It may belong to a range of worlds, each shaped by its own kind of patience. And in asking which planets might be better than Earth, we are also asking whether our definition of home has been too small all along. What if the most important discovery is not that better worlds may exist, but that we are finally learning how little we still know? For all our telescopes and equations, distant planets remain largely invisible in the human sense. We cannot stand beneath their skies. We cannot place a hand in their soil, or hear the weather move across their plains. Most of what we know comes indirectly, translated from light into numbers, and from numbers into informed imagination. It is a remarkable achievement, but it is also a reminder that science often advances by carefully honoring uncertainty rather than defeating it. That uncertainty matters because the universe is skilled at misleading first impressions. A planet in the habitable zone may have no meaningful atmosphere. A promising mass may conceal a crushing envelope of gas. Water may exist, but only as steam or ice. A quiet orbit may surround a star with a violent past. Again and again, researchers are forced to refine, revise, and sometimes let go of worlds once celebrated as hopeful. This is not failure. It is the discipline of learning to see clearly, and still, the picture grows richer. New instruments are beginning to analyze the atmospheres of select exoplanets, searching for chemical traces that might hint at climate, clouds, or perhaps even biology. Oxygen, methane, carbon dioxide, water vapor, none of these alone would prove life, but together they form the beginning of a language, a way of asking distant worlds what kinds of stories their skies have been telling for billions of years. There is something deeply moving in that effort. We are a species made of local materials, carbon, salt, memory, breath, trying to interpret the chemistry of suns we will never touch. We are fragile creatures building tools sensitive enough to detect the possible weather of another age, another place. However advanced the instruments become, that act retains a kind of tenderness. Because at its heart, this search is not just for planets, it is for context. We want to know whether life is a rare interruption in cosmic silence or whether the universe has been full of inhabited experiments all along, waiting for someone, somewhere, to notice the pattern. What if the search for distant worlds is really a mirror turned back on Earth, asking us to see our own planet with newly educated wonder? It is easy, in conversations about superhabitable planets and better climates, to let imagination drift outwards so completely that Earth begins to feel ordinary. But the opposite may be true. The more we study other worlds, the more astonishing our own becomes. Not because it is unmatched, but because we are finally learning how much had to converge for this one blue planet to become a place of memory, language, grief, love, and thought. Earth is not simple. It is a negotiation between ocean and rock, atmosphere and sunlight, disaster and recovery. Countless species have lived and vanished here, each one altering the conditions for those that followed. Forests changed the air, microbes reshaped chemistry, extinction cleared ecological space for unfamiliar futures. Life did not merely adapt to Earth. Life helped build the Earth we inherited. That recognition adds a subtle weight to the search beyond our solar system. When we look for other habitable worlds, we are not only asking where life could begin, we are asking what long chain of relationships might sustain it. A livable planet may be more than a correct temperature or a favorable orbit. It may be an entire history of cooperation between matter and time, between vulnerability and persistence. This is where astronomy becomes intimate. The farther outward it reaches, the more it returns us to basic human questions. What allows something fragile to last? What turns survival into meaning? What transforms chemistry into consciousness and consciousness into care? These are scientific questions, yes, but they are also the questions that sit quietly beneath every family story, every graveyard, every work of art. Perhaps that is why the idea of other, gentler worlds moves us so deeply. Not because we wish to abandon Earth, but because we sense in those distant possibilities a wider frame for our own existence. And when we finally imagine life thriving elsewhere, under another sky, the lesson may not be that Earth was never enough. It may be that life, wherever it appears, is always more miraculous than the world that holds it at first seems able to explain. What if the true significance of these distant worlds is not that we might reach them, but that they quietly change the scale of our thinking? No ship we can build today will cross the Gulf to Kepler 4442b or any other promising candidate within a human lifetime. Even their names remind us of distance, more than intimacy, catalog numbers, coordinates, faint signatures in a database of light. And yet they have already altered us. They have expanded the emotional architecture of the future. They have made the cosmos feel less like a backdrop and more like a field of unrealized possibilities. That matters because human beings live not only by what is present, but by what can be imagined responsibly. We tell stories forward. We build meaning from horizons. The moment science allowed us to consider that some worlds may be older, calmer, and in certain respects more hospitable than Earth, it introduced a new kind of humility into modern life. Not the humility of insignificance, but the humility of participation. We may not be the summit of habitability. We may be one local expression of a much larger experiment. There is comfort in that, if we let there be. It means life is not necessarily a fragile accident balanced on a single point of failure. It may be a recurring tendency of matter under the right conditions, a quiet insistence written into the chemistry of the universe. And if that is true, then existence itself becomes less lonely even before proof arrives. Still, distance protects mystery. These worlds remain beyond touch, beyond migration, beyond rescue. They do not offer escape from the responsibilities of Earth. In fact, they sharpen them. The better we understand how rare and intricate habitable conditions may be, the more clearly we see what is at stake here at home, on the one world already filled with voices, memory, and unfinished human promises. Perhaps that is the paradox. The farther our minds travel, the more accountable we become to the ground beneath us. And so these planets endure in our imagination, not as destinations, but as teachers, silent, remote, and luminous, with a lesson we are still learning. That wonder is not diminished when shared across many worlds. It is deepened. So where does this leave us after the long sweep from distant starlight to the inward questions it awakens? It leaves us, perhaps, where all meaningful journeys end, not with certainty, but with a clearer sense of proportion. The universe may contain worlds more temperate than Earth, older than Earth, quieter in their geological and stellar rhythms, more generous with time than the planet that gave rise to us. Some may hold broader oceans, steadier climates, longer biological futures. Some may never host life at all. And most, for now, remain suspended between evidence and imagination, real in their physics, yet unfinished in our understanding. But the deeper revelation is not simply that better candidates may exist, it is that habitability was never a single formula. It is a story of balance, of atmosphere and stone, heat and patience, accident and endurance. Earth was not perfect. It was enough. Enough for cells to awaken, for forests to breathe, for animals to wander, for memory to become language, and for language to become the tool by which the universe finally began asking questions about itself. That is no small thing. To imagine other worlds surpassing ours in some respects is not to diminish human life. It is to place it within a grander companionship. We are not the owners of cosmic meaning. We are participants in it. One species on one planet, under one star, trying to understand whether life is a rare candle or a widespread glow moving quietly through the dark. And maybe that is the lasting insight. The search for worlds better suited to life than Earth does not end by making our home seem lesser. It makes it more poignant, more contingent, more worthy of attention. Because once you understand how much must align for a living world to endure, you stop seeing Earth as ordinary. You see it as a beginning, and beyond it, in the vastness, other beginnings may be waiting, other histories of water and time, other forms of wonder beneath unfamiliar suns. The question is no longer whether the universe is large enough for such possibilities. It almost certainly is. The question is whether we are wise enough to meet that knowledge with humility, gratitude, and care. For distant worlds we may never see, and for the one world that taught us how to look.